Alrighty, you guys, welcome to your lesson that's all about chemical equations. So this lesson can be a little bit tricky if you need to go slow and pause and take notes and jot your own things down. I encourage you to do so. Also, always remember that your teachers are here to support you. So reach out to us if you have any questions as you go through the lesson. So first, let's talk about chemical equations. Chemical equations are a line of mathematic information that will yield something, okay? So just like 1 plus 1 equals 2, a chemical equation is very similar. You have a reactant plus a reactant, and it's going to equal a product. And this is how we write down how atoms and molecules are bonding with one another to create something else. Now, I want you to remember that matter cannot be created or destroyed. So what we hope to see at the end of every chemical equation is something that equals to what we had at the very beginning, and I'll explain that further as we go along. But let's talk about exactly what makes up a chemical equation. So we can describe chemical reactions in a very similar way that we often text. So cell phone messages, and we use symbols and abbreviations to express ideas that are in shorter form. Instead of saying, "What's up, Joe?" we say, "Sup, Joe?" Or we say, "NMU," nothing much, you, right? Instead of having to type all that out. I know it saves us so much time. But when we write down chemical equations, we're essentially doing the same thing. We're taking what we know and we're putting it into a much shorter form that has to be often decoded. Okay, so here is an example of a chemical equation. What does the information from the first side represent? The first slide. This would be the same equation that I had up there on the screen on the very first slide. What does this represent? Okay, this is showing us photosynthesis. I know you guys know all about photosynthesis, but you might not have seen it as a chemical equation before. Let's talk about what it means. Remember I mentioned that what's on this side would be a reactant. Remember we had like 1 plus 1 equals, and then the product would be 2. Okay, this is just an example. We do not have 1 plus 1 equals 2 here in this chemical equation, but hopefully now you understand how we read it. Okay, so remember that things that combine together and undergo change are called reactants. That's this. Okay, and then together they're going to yield, which is the arrows, and something new, a new substance. And that is called the product, and it's written after the arrows. Remember I mentioned the law of conservation of mass. This is telling us that mass can neither be created nor destroyed in a chemical reaction. So whatever we have in the reactants always must equal whatever we get when we finish the reaction in the products. The products has to always equal whatever we started with. Whatever we started with has to equal what we end with, okay? We can't create something new and wind up with more. We can't get rid of anything and wind up with less. They have to be equal, okay? The law says that mass cannot be created or destroyed, but it changes form. So it might not look exactly the same when it comes out on the product side, right? It might be a different combination. But if we add everything up by counting the atoms and counting the molecules and knowing how many atoms are in each one, then we'll make sure that we follow the law of conservation of mass. The total number of atoms on one side of the equation must equal the total number of atoms on the other side. So, for example, this one's pretty easy. We've got iron, and it's going to react with sulfur. These are our reactants, and our product is iron sulfide. Boom, they get together. I can count this pretty easily. I've got 1 iron and I've got 1 sulfur, and they combine together and I wind up with 1 iron and 1 sulfur. Pretty easy. Gets a lot more complicated, but now we've hopefully set the groundwork to further understand the principle and the law of conservation of mass. So here's some practice. What are the reactants? The reactants are anything that's on this side. They're what's going to combine together and cause a reaction. What are the products? The products are anything on the other side. They are the result of the reaction. Okay? So, how many molecules in each element or compound are needed for this reaction to take place? Let's count. First, let's count the reactants. Okay? Bum, bum, bum. The reactants. I know that in this side, in the red side, I've got some number of N's, I've got some number of H's, and I've got some number of O's. Let's count each. I've got 2 N's, N equals 2. I've got 4 H's, H equals 4. And I've got 2 oxygens. Okay, so we have to make sure that we wind up with the same. It doesn't look like we're going to wind up with the same on the other side. Let's see. Let's try it. First, I've got some number of N's. I've got some number of H. And I've got some number of O. Okay. I have 2 N's. I've got 2 H's. And I've got 2 O's. Oh, I'm sorry, I don't have 2 O's. I only have 1 O. There's not a 2 over here. There's just an O. So that means that I've got 1. So first, is this a balanced equation? Do they equal each other? No, it is unbalanced. But remember, I'm going to write unbal there. But remember, the law of conservation of mass tells us that it has to be balanced, that it has to be equal on both sides. Oh no, what am I going to do? Well, I can add a coefficient. If I add the number 2 here, then I've got 2 times 2, and that's going to equal now 4. And I've got my 1O times 2, and now that's going to equal 2. And now they are balanced. And that's what we want. We want to be able to make sure that all of our equations are balanced at the end when we see the products, okay? So this was a quick one. Let's try one more. Let's try one more. Boop. Okay, first we have to look at the elements that we have here in our reactants. Let's start with the reactants. So that's this side, right? Starting here. What are the elements that we have here? Well, I see Ag. I see an N. Remember, an element always begins with a capital letter. Sometimes there might be a lowercase letter that is beside it. Okay, so Ag, N, and O, that's this side of the reactants. Let's do the next. We've got K. We've got Cr. We've got another O, so I'm not going to rewrite the O, I'm just going to keep it up there. Okay, those are all the elements that I have in the reactants. Let's count them. Remember that if I don't see a little tiny number that's called a subscript beside an element, then I can assume that that element is just one atom. Okay, so Ag, there's no subscript, so I'm going to write my little invisible one there, and I'm going to say I've got 1 Ag. I don't have a subscript by the end, so there's an invisible little 1 there. I've got 1 N. But look, I've got 3 oxygens. Okay, I've got 2 K. And I've got Cr, and that's invisible little 1. But look, I've got 4 more oxygens, okay? So that's going to be a total of 7, okay? This is how many I have on the reactant side. Okay, reactant. Let's look at how many I have on the product. Reactant. Okay, so products. Let's do that in a different color so that way we can really see it. I'm going to look at their products. I'm going to put those in red. Here we go. I've got an AG. I've got a CR. I've got an O. I've got a K and an N and another O. I'm not going to rewrite the other O. Okay, so far that matches. AG, AG, N, N, O, O, K, K, CR, CR. So we have the same elements on both the reactants and the products. We're off to a good start. Let's count the products. So I have 2 AGs. I don't have a subscript here, so I can assume that there's a little invisible one by that CR. There's 4 oxygens, at least in that part, right? Okay, but now look. There's a coefficient here of a 2. Remember that that coefficient of the 2 is going to apply to the entire line. So anything that I see in this line, I'm going to multiply back to the 2. So there's not a subscript here by the K, so I'm going to put my invisible 1, but now that's that 1 times 2. So I've got 2 Ks. Okay? There's not a subscript here by the N, so I'm going to write in my invisible 1, but remember I multiply that 1 by that 2, and I've got 2 N's. Okay, now here's the tricky part. I've got a 3 here, but remember, I have to multiply it back to that 2. So that means I've got 6 oxygens. Okay, so here is my total. Do my AGs match? Does AG match? No, it doesn't match. Does the N's match? 1 and 2? Nope. They don't match. I've got a total of 7 here, but a total of 10 here. Do they match? No. 2 Ks, 2 Ks. Well, yeah, that matches. That's good. CR matches, and that's good. But overall, is it balanced or unbalanced? No, it is unbalanced. This is an unbalanced chemical reaction. Was the law of conservation of mass followed? No, hard pass. It was not followed. Okay. I hope that this helped clear up how to use a chemical equation to see how the law of conservation of mass would be followed, how to count the different atoms in a molecule and in an equation, how to compare the reactant side versus the product side to see if it's a balanced equation or unbalanced. If you have any questions, you know where to find us. I know that this is a tricky lesson. Your teachers have plenty of additional resources and practice problems for you, so make sure that you're reaching out and attending your live classes if you need assistance. Thanks so much, you guys. Good luck.